Another way that we can express roots is with rational exponents. So let's see that written out. Rational exponents, because it's going to be something I mention a few times. Rational exponents. So an exponent we probably know well, but if rational is a little unfamiliar, and we'll see it in some future videos as well, essentially means a fraction. So what we're having here are fraction exponents. So let's say we're taking the nth root of a to the power of m. What we can do is rewrite this as keeping that base of a, and then our exponent of m goes in the numerator, and the root that we're taking goes in the denominator. So what we can do is re-express these roots as a fractional exponent or a rational exponent. And another way we could see this is actually as the nth root of a, and then on the outside of that, raising it to the power of m. But m is an exponent, n is an index of a root, and the index goes in the denominator, exponent goes in the numerator. So let's look at some examples with this. So if I have 81 to the 1/4 power, so the 4 is the index for my radical, because that's in the denominator. I have an exponent of 1, which doesn't really do anything, so I can just think of this as 81 underneath the 4th root. And with that, I'm thinking what to the 4th power gives us 81, and that should be 3. And that would simplify it down. If I have 8 to the 2/3 power, now there's two ways we can go with this, especially if we're trying to do calculations without a calculator. Sometimes one way is easier than the other. So 3 is in our denominator, so that's going to be the index. And then I have 8, and that 2 is an exponent and can either be inside the radical or outside the radical. So I could either write this as the cube root of 8 squared, or I could write this as the cube root of 8 all squared. So this would be the cube root of 64, which we can get to the answer with that. Yeah, but I kind of like this other version better, because I know the cube root of 8 really well, and that's a 2. And then outside of 2, we're squaring it, and that'll get us a result of 4. So that one's a little faster for me without a calculator, just because I know the cube root of 8 so well as being a 2. So it keeps the numbers kind of small to work with if we change it into that form. This cube root of 64, we could have gotten there seeing that 4 times 4 times 4 is 64. So we know the cube root of 64 is 4. It just takes a little bit more brain power. But either way can get you to the answer there. All right, let's get a refresher of our negative exponents. So if we think of this as 125 over 1, that negative exponent tells me move to the denominator. So we're going to go 1 over 125 as our base, change the sign, so we'll have a positive 1/3, which is the same as 1 over cube root of 125 to the power of 1, which power of 1 isn't going to change things. 125 is made up of 5 times 5 times 5. And actually, let's bring this to another line down here. So the cube root of 125 is going to be a positive 5. And that would be our answer there. Let's do another one here. So, move to the denominator. So we'll have 1 over 216 to the positive 4/3 power is equal to 1 over, I'm going to see if I can take the cube root first of 216 to make the value a bit smaller, and then raise it to the 4th power. Now 216, just personally, is a value I'm not particularly familiar with, so I'm going to play with the prime factorization. So I know that's divisible by 2, and that would give us 108 left over. That's also divisible by 2, which would leave us with a 54. All right, 54 I know comes from a 9 times 6, which is a 3 and 3, and a 2 and 3. Okay, so I'm seeing some pairings of 3s here. I'm just talking you through my process here. So I see I have, and it's not pairing, sorry, because it's a cube root. I'm looking for threesomes. So I have a threesomes of 2s. I also have a threesome of 3s. So what I could do to help me out here, I'm going to write in long form, but you could probably do it from that step there. But I could write this as the cube root of 2 times 2 times 2 times 3 times 3 times 3. And then all of that is being raised to the 4th power. So that cube root is going to come down to a 2 times 3, because we're going to group those together as a threesome and that together as a threesome. So we'll have a 2 times 3, which is 6, and that's being raised to the 4th power, which is a 36 times 36. Let's see, 6 to the 4th power, so 1,296. That can get us there. Okay, let's go ahead and look at some scenarios here for simplifying expressions that have variables involved. And some things that are going to come through here is mixing these properties of roots and exponents. So we're going to see some exponent properties here as well. So, like this cube root of 8 times x to the 6th times y to the 12th. What we could do is have this as the cube root of 8 times the cube root of x to the 6th times the cube root of y to the 12th. What this lets me do is see cube root of 8. I know that's a 2. Cube root of x to the 6th, we could start simplifying, but what I want to show us here is how we can use our rational exponents to help us. So we have x to the 6th, and we're actually can even go one step more easily of we have our exponent, we have our index. So what I can do is express this as x to the 6th power divided by 3. And same thing here with y to the 12th power divided by 3. So always dividing by that index. And then we can simplify those fractions. So that would be 2x, 6 divided by 3 is a 2. Y to the 12 divided by 3, which is 4. So that we can simplify fractions in these exponents just as we would with other arithmetic. Let's take a look here. So we have the 4th root of 81 times the 4th root of x to the 8th power times 4th root of y to the 20th power. So 4th root of 81 should be a 3. We have x to the 8/4, y to the 20/4, which simplifying those fractions, we'll have 3 times x, and that'll be squared, and y to the 5th. Okay. Here we would have 5th root of negative 125 times the 5th root of x to the 5th times 5th root of y to the 10th. Ooh, let's take a look at 125. So 125 I know comes from a 5 times 5 times 5. That's going to be stuck. Yeah. So I was going to start writing out the prime factorization, but I don't really have much to write there. So that's going to be stuck underneath the radical. Let's see here. And then, so I'm going to keep that out front, but then I'll move it later on. X to the 5/5 times y to the 10/5. So we're getting x to a power of 1, y to a power of 2. That y kind of got away from me. And then we're going to still have fifth root of negative 125 as our radical portion. Okay, last one here. We have third root of 128, third root of a to the 7th, third root of b to the 4th. Now, something that's going to happen with this one is when I make my fractions, they're not going to be very nice. 7 divided by 3, ugh. But this is where prime factorization could help us out. So let's talk about 128 for a second, just to see numerically what we're going to get out of that cube root. So let's see, that's a 2 times 64, which is a 2 times 32. Oh boy, this is going to be lots of 2's. 2 times 16, 4 times 4, which is 2, 2, 2, 2. So let's see. 128 is made up of 1, 2, 3, 4, 5, 6, 7 2's multiplying together. Let's write this out. We'll just go the exhaustive route with this one. So that is the cube root of 7 2's multiplying together. 2, 3, 4, 5, 6, 7. Times the third root, and we have 7 a's multiplying together. And then multiplying with the cube root of 4 b's multiplying together. I'll show you a shorter route after this, or another way of thinking of it, but just in case. There we can see grouping of 3, grouping of 3. So we're going to have 2 2's come out. So it's like we have 2 times the cube root of 2. And then with the a's, we have 1, 2, and then an a stuck underneath. So we'll have an a outside, another a outside, and then 1 a still trapped underneath. Times, and then b's will have a grouping of 3. So 1 b will come out, but then we'll still have a b underneath. So we'll have 4a squared b cube root of 2 times a times b. Let's quickly talk through another way we could have done this without the prime factorizations. So if we had known 128 is the same as 2 to the 7th, so it would be 2 to the 7th, a to the 7th, b to the 4th. And then if I brought that index through, so dividing by 3, dividing by 3, dividing by 3. So what I could have done is thought of this as 2, and then just going 1 less, I would have had 6 over 3, but I still have 1 2 left over. Same thing with the a's. I could have written that as 6 over 3, but I still have an a left over, so I'd have a with a 1/3. And then with the b's, if I bumped down by 1, I would have had 3 over 3, but I still had 1 left over. So 2 to the 6/3 is 2 squared, and then I still have this cube root of 2. And then times a squared, and then I still had this cube root of a, and then I had 1b, but I still had a cube root of b. And with that, we could have gone to the same answer of 4a squared b, and then a cube root, and all underneath was a 2 and an a and a b. So it's what's happening when you have improper fractions coming through in the exponents, and kind of think of what's the whole value that I could take out, and then what would I have left over? And those leftovers are what's going to be stuck underneath your radical still. But then any whole numbers you can get out will be the things outside of the radical.